Welcome to The Explainer. So glad you're joining us. Today we're unpacking a really fascinating chapter all about the shaping of the Earth's surface. We're going on an incredible journey into the immense, hidden forces that build our planet up and, well, the relentless elements that wear it right back down. If you've ever stood in front of a massive mountain range or looked out over a sweeping river delta and thought, how in the world did that get there? You're absolutely in the right place. Let's just dive right in. So what if the solid ground beneath your feet is actually moving? I know, it's a wild thought, right? We build our houses, our cities, literally our entire lives on the assumption that the Earth is this static, unchanging foundation. But as the source material for this chapter reveals, that is actually a complete illusion. Our planet is incredibly dynamic. It's constantly transforming, both from deep within and from way up above. To wrap our heads around how this works, here's our agenda for this inside-out journey. First, inside the Earth. Second, the moving tectonic puzzle. Third, sculpting the surface. And finally, when landscapes turn deadly. Okay, kicking things off with Section 1, Inside the Earth, the hidden engine. We really need to strip away the surface to see what's powering all this change. And what's super interesting is just how extreme the interior of our planet actually is. We live on the crust, the outermost shell, which is surprisingly thin. We're talking only about 5 to 7 kilometers under the oceans and maybe 30 to 40 kilometers under the continents. Just below that is the mantle, which is this massively thick, mostly solid layer. And then, right in the center, we have the core. The inner core is a solid, extremely hot spinning metal ball, completely surrounded by a fluid outer core of iron and nickel. To put that into perspective, that inner core is roughly as hot as the surface of the sun. This intense, fiery heat at the very center of the Earth is the hidden planetary engine that drives literally everything we're about to talk about.
So the absolutely crucial point here is understanding how our surface interacts with that deep, deep heat. Enter the lithosphere. This is the rigid outer layer of the Earth, made up of the crust and the very upper part of the mantle. But here's the really fascinating part. This solid, rocky lithosphere doesn't just sit there rigidly. It actually floats. Just beneath it is the asthenosphere, which is a hot, semi-molten layer of mobile rock. Because the asthenosphere is, partially melted and squishy, it allows the rigid lithosphere right on top of it to slide and move around.
Which perfectly sets us up for Section 2, the moving tectonic puzzle. Because, as we're learning from the chapter, the lithosphere isn't just one solid shell. It's shattered. This brings us to plate tectonics, an incredibly important theory introduced by W.J. Morgan. I want you to imagine the Earth's outer layer as a giant, cracked eggshell. These massive slabs of solid rock are called tectonic plates, and they move very slowly over that semi-molten asthenosphere we just talked about. We're talking usually just a few centimeters a year, which, funny enough, is about the exact same speed your fingernails grow. But it's at the edges of these plates, the boundaries, where the real magic, and honestly the chaos, happens. There are 3 main ways these puzzle pieces interact. They can be convergent, meaning they're moving towards each other, divergent, moving apart, or transform, where they're just sliding right past one another. And these different boundary interactions build completely different landscapes. When we have a convergent boundary, it's a massive collision. When 2 continental plates crash into each other, they crumple upwards, creating massive fold mountains. That's actually exactly how the breathtaking Himalayas were formed. On the flip side, we have divergent boundaries. Here, the plates are pulling apart. When this happens, magma rises up from the mantle below, cools down, and actually forms brand new crust. This creates massive underwater mountain ranges, like the Mid-Atlantic Ridge. So think of it this way. One force builds by crashing, and the other builds by tearing apart. But all of this constant movement comes with a whole lot of friction. In fact, most of the world's earthquakes and volcanoes occur right along these plate boundaries. And nowhere is this more evident than the Ring of Fire. This is a massive, incredibly active zone that surrounds the Pacific Ocean. If you map it out, this ring traces the edges of the continents perfectly. The constant grinding and sinking of tectonic plates here create intense zones of geologic violence. It's a pretty stark reminder that the engine beneath our feet is literally always running. All right, let's transition over to Section 3, Sculpting the Surface. If internal tectonic forces act as the builders pushing the Earth up, we now need to look at the external forces that wear it back down. The main sculptor in this process is erosion. Now, weathering is when rocks are just broken down, right in place. But erosion? Erosion is an active sculptor. It's the process by which materials are worn away and, crucially, carried to another place by natural agents. Things like water, wind, ice and glaciers, and ocean waves act almost like chisels and sandpaper, constantly reshaping the landforms created by those tectonic plates. And this brilliantly illustrates the diverse power of erosion. Just look at the Sundarbans Delta, for example. This incredibly lush, complex network of waterways is completely carved out and deposited by river erosion. The water actively carries soil and deposits it down the line, creating rich, super fertile land. Now contrast that with a harsh, dry desert landscape. Here, the main sculptor is the wind. Wind erosion whips sand against rocks over thousands of years, carving out these striking, jagged formations. It's the exact same process, erosion, but with entirely different natural agents, resulting in completely opposite landscapes. Pretty wild, right?
But you know what's really amazing? It's how humans have had to adapt to these shaping forces over time. Ancient civilizations were incredibly attuned to the land. The Sindhu-Sarasvati civilization, for example, developed highly sophisticated water management techniques to handle the power of river erosion and flow. They used contouring, bunding, terracing, and built impressive dams and canals. These practices were so vital they were actually meticulously documented in ancient texts, like Kautilya's Arthashastra, which even provided guidelines on land assessment based on how fertile it was. They absolutely understood that to survive and thrive, you have to work with the forces sculpting the surface, not against them.
But sometimes working with these forces becomes impossible, which brings us to our final section, when landscapes turn deadly. We so often think of geology as agonizingly slow, mountains rising over millions of years. But the tragic reality explored in this chapter is that these forces can sometimes act with terrifying suddenness. Take February 2021, when a devastating glacial lake outburst flood, often called a GLOF, struck the Chamoli district in Uttarakhand. A massive volume of water, ice, and debris suddenly rushed down the valley. It wiped out buildings, roads, and hydel projects in a matter of moments, tragically costing many human and animal lives. It's such a powerful contrast, the slow, steady carving of a glacial valley over millennia versus the terrifying speed of a sudden geological disaster.
And disasters certainly aren't just limited to water and ice. Wind erosion can also turn lethal in the form of massive dust storms. But what actually drives them? Well, it's often a combination of natural forces and human impact. Prolonged drought naturally dries out the soil, but then human activities like deforestation, overgrazing, and poor farming practices remove the vegetation that normally holds that soil in place. You throw in extreme weather driven by climate change, and you have the absolute perfect recipe for a blinding, choking disaster. Just visualize the sheer power of this kind of storm for a second. We're talking about strong winds lifting literal tons of loose, dry soil and sand high into the air, completely obscuring the entire landscape. This isn't just a day of bad weather. This is rapid, aggressive wind erosion happening right in front of our eyes. It strips the topsoil away, devastating agriculture, and poses severe health risks to anyone or anything breathing it in. It just goes to show how our own actions, like removing vegetation cover, can directly amplify the dangerous extremes of the Earth's natural surface forces.
Which brings us right back to the core thesis of this entire chapter we're exploring today. The Earth's surface is not consistent. It is constantly being transformed by powerful forces acting from within and on the surface. From the fiery heat of the inner core driving massive tectonic plates to crash into one another, to the slow, steady patience of a river carving out a delta, to the sudden devastation of a glacial flood, our planet is a dynamic, living engine. It is never truly at rest. So, I want to leave you with this thought to mull over. The Earth is constantly rewriting its own map. The mountains are going to shift, the valleys will carve deeper, and the plates will continue their slow, grinding dance. We are really just temporary residents on these moving puzzle pieces. The question is, as the Earth continues to change and reshape itself, how will humanity adapt to the next draft? Thank you so much for joining me on this explainer. Keep asking questions, stay curious, and I'll catch you next time.